Here we have Vernier Graphical Analysis ready to do some measurements. We're going to do a friction measurement. So the first thing I want to do is hit Sensor Data Collection. And I've got a Bluetooth sensor in front of it, and that's the one. So I hit Connect. And done. And we should be ready to collect data. Now the data is going to end after 5 seconds. I can change that here, but I think I'm going to keep it at 5 seconds and just make sure that I promptly start the measurement once I hit Collect. What else? Okay, so you can see the force is already showing almost 1 Newton in here. So before you start a measurement, you want to click here and zero it. So I just zeroed it, and now I'm going to hook up the sensor to the box, which is going to pull 1 kilogram. So this is a 1 kilogram run, and we're going to pull it at constant velocity, and let's give this a try. So collect. And that is my 1 kilogram pull. Okay, fair enough. Let's put a second kilogram on here, and I'm going to do it. So here's collect, and I'm going to start pulling at constant velocity. And I can come here, and I can take a look at both of them. This kind of makes sense. So this is the 1 kilogram one. This is the 2 kilogram. Okay, well, let's put 3 kilograms into our box that we're pulling and hit collect, and then try to pull at a constant velocity. And again, I kind of want to make sure everything is behaving as expected. So it didn't go up quite as much relative to the other one, interestingly enough. So it doesn't look linear, but that's okay. We're just taking data. So I'm going to come over here and finally put a 4th kilogram in here. So this measurement is 4 kilograms. So collect. And we have that one. So that's 4 kilograms. And again, let's go back and just take a look at all of them. So they're kind of behaving right. I mean, they're shifted horizontally a little bit because I don't always start to pull at the same time. But they seem to be working okay. You'll notice that there is a little peak here, suggesting that I have to pull a little harder, and then once I get it going, it works well there. So well, this data looks encouraging. Let's add another kilogram. So I'm adding another kilogram to the object that I'm pulling, which is going to increase its weight, and therefore its normal force. So the normal force here is higher, and we're going to collect and pull. And let me just get some more measurements here before looking at them all. So that's 6. This will be, next one will be 6. There's collect and pull. It looks like we could almost go a little further in time to get to the flat region, because I'm not quite getting back to constant velocity here, I don't think. So let's put another kilogram. This is 7 kilograms. And I'm not going to mess with the time scale. I'm going to keep it at 5. But I'm going to try to start a little more quickly. So there. And okay, that was a little better. So that was 7. 7. And now, let me see if I can squeeze them all in here. This is going to be 8 kilograms. So collect and pull. Let's go 9 kilograms. Here we go. Collect. Pull. And finally, our last measurement will be 10 kilograms. And the structural integrity of our system is being pushed here, because that's a lot of weight. So we'll collect and pull out like that. Okay, so what this is is a set of 10 measurements going from 1 kilogram to 10 kilograms. In other words, about 10 newtons to 100 newtons. And it's kind of a mess at this point because, again, they're not synchronized in when they start. But I think if we come out here like at 4 seconds, we can maybe get an idea of how they compare with respect to, out here we would be measuring the kinetic coefficient of friction. So this is a pretty cool tool. If you just click anywhere here, it's going to give you this line, which gives you at that particular instantaneous point the values. So you can just record these. I like to get a screenshot of this and use that. But on the other hand, what we also might need to do for some of these is go here and let's say, let's hide them all at one. If anybody figures out how to use the cleanly use the statistics without leaving just one, let me know. So this one is what? This one is, whoops. Okay, this is the 1 kilogram. So what we can do here is we can come to, we can just grab maybe this chunk here. Maybe that's steady state. And then come over here and click statistics. And it's going to give us the statistics. So you can see these little brackets here. So what's going on here is all the data within the brackets is being statistically analyzed, and you get a mean of 2.3. Standard deviation of that number. You get your min and your max. Really, the mean is all we're interested in here. And if you come here and you just randomly grab a spot like we did before, you get 2.23, and this is 2.30. So there may be instances in which this method is better, but oftentimes that other method with when we had them all showing at the same time at one particular point might be adequate. Okay, so at this point what we want to do is we want to do a couple things. We want to come up here to Untitled and we want to go Save As, and we want to name this. So I'm going to name this experiment. This is experiment D for me. I did 3 yesterday, and I always like to put the date. I've lost data in the past because I didn't document it well enough. So here's experiment D, and then also you can put here, so this is sandpaper, black table, and 1 through 10 kilograms. So the name of the file tells you everything you need to know there. So I can click there. And what that should do is give us a, where is that? It's right here. It's a so-called Gamble file, which we can read back up into Vernier graphical analysis. But actually, that may or may not be that useful. It will at times, but I like to do export because I'm a person who likes to do analysis in a spreadsheet. So you can export a graph, you can save a PNG, you can do a PDF. I want you all to go to CSV, comma separated values, and save it, and I am going to name it similarly. I don't want to have to rewrite that whole thing, but I want to show all the files here, and it's not letting me. So I'm going to have to just do that over again. This is experiment. Oh, there it is. Experiment D, but I don't want the Gamble extension. I want the extension it's going to attach, which is CSV. So we'll save that, and we can leave here. And if we go to that file, and whoops, where'd it go? Experiment D. Oh, Microsoft Excel. So yeah, so you get the data here. We'll do this not in Excel, but we'll do it in Google Sheets. So you have that, and also one thing you can do from here is say you want to just show the overall behavior, that the frictional force increases as it should as you add more normal force to the object we're pulling. And you can see sort of the shape is also changing. There's a way to export an image of this, but I like to just grab it with my own tool, and we can come up here, and I am going to, these are some other things that I've done, so I'm going to make a copy of, I'm just going to make a new, experiment D is going to be after this blank, so I'm going to just paste this in here. And now we can decorate it nicely with things like text boxes, which says, okay, so this has a normal force Fn. To make a subscript, it's control comma, and so control comma back out equals, that's some number of newtons, so that's about 100 newtons at 10 grams, 10 kilograms. So that's 100 newtons. And you can use these lines here like so. And this is pretty messy, so I don't know if you want to do all of these, but it can give you an idea of the evolution of the measurements. Now, in terms of doing the analysis, I did my analysis in Sheets here, and so I uploaded that. Well, I just had a column for run, the mass that I added, and then the total mass, because the mass of the box without the sandpaper, this is one without the sandpaper, is 55 grams. So I add that in to get this. And then this is the normal force. So what this is, it's a little formula which says multiply column C by 9.8. And then finally, for the friction force, in this particular case, since the data was very well behaved, I think I have a picture of it somewhere, not in this document. Anyway, so you can see I just read it off here. And I put it in here, and I plotted it, and I got a nice straight line, the slope of which should be the coefficient of kinetic friction. Okay, so these are ways you can use VGA, Vernier Graphical Analysis Program, and you can get screenshots, you can open up your own slides, not slides, sheets, spreadsheets, and you can do it in here. You could do it manually, but if you're at all comfortable with spreadsheets, that's a better way, and you can get this value. So this is kind of stuff we want to be doing today, and so I will end the video here, and I'm going to go and I'm going to create this video, this graph here. I'm concerned that this is too long of a video, but if I were to do this, what I might do is just a first run is go back, say, over about here, and I would just grab this thing, a screenshot, and I would paste that into my, let me make a new folder called, this is D, so this is black table, sandpaper, and large masses. And I would fill out my headers and stuff, but the bottom line is that I couldn't put that image in there. So what you got to do, unfortunately, is you got to save this first. So I'm going to save it as experiment D, values at 1 point. So what that means is values at 1 point. And you can come over here and you can say insert image. You want to insert it over the cells, so I can browse here and grab this guy. Now I've got this here that I can just refer to. So as I start to make my table here, I can just read off. So this is the frictional force directly. So once I have the normal force here, I can put the frictional force here, and then I can grab it, insert, chart, make a scatter chart, trend line, and you'll be off and running on that. Okay, I'm going to end the video here. Thanks for watching. I'll see you next time.